So I have your sample problem regarding the losses. So properly matched transmission line has a loss of 1.5 decibels per 100 meters. So yung mga losses ng mga transline, they are expressed in terms of decibel per meter. Okay, so may mga ganyan sila. This is actually attenuation. May mga ganitong measurement. So remember yung kanina, yung attenuation coefficient. So pwede siyang naka-express in nepers per meter, pwede siyang dB per kilometer, or dB per 100 meters, kagaya mo nandito. So dito papakita ko sa inyo paano i-solve yung mga attenuation problem. So this is an attenuation problem. Attenuation is always present sa cables and other transmission media. Okay, so if we have this cable with a loss of 1.5 dB per 100 meters of cable, so the 10 watts is supplied to one end of the line. So how many watts reach the load? 27 meters away. If you're going to visualize yung system, for example, transmitter receiver, so this is 27 meters apart. Okay, based on sa problem. If 10 watts is supplied dito sa point na to, so ilan kaya ang ma-receive ng kabilang end? If yung cable mo may loss siya ng 1.5 dB per 100 meters. So this is how you compute for the power. So you can compute the power ng mas mabilis kapag naka-decibel sila. So gawin mo lang ng ganito. Okay, so this is parang natin working equation mo dyan. So try to remember this working equation for that particular problem. Kapag attenuation. So kung i-solve ko siya, kung start tayo sa 10 watts, so kailangan mo i-decibel watts yan. Okay, so paano ba i-dB watts? So just get the 10 logarithm of 10 watts. So dB watts na siya. Minus, kasi loss to. So loss to, di ba? So A is for attenuation, L is for the length or the distance. So nag-attenuate siya or may attenuation yung cable mo na 1.5 dB for every 100 meters. Kaya hindi naman 100 meters yun, so 27 lang. So multiply mo yung 27 to get the total loss. So actually ito yung total loss ng, pag gusto mo malaman yung total loss ng cable given yung particular length or yung distance ng dalawang points, so just multiply the dB per length doon sa length. Okay? So naka-decibel nga lang yung sagot dito. So depende kung anong kailangan mong sagot. So pwede mo naman siyang ibalik sa watts if you want. So let's calculate. So 10 log 10 minus 1.5 over 100. Then multiply dun sa distance or dun sa length. So this is 9.6 decibel. So kung gusto mo i-antilog, so paano ba mag-antilog ulit? So 10 raised to 9.6 over 10. So ibabalik mo siya sa watts. So ganito gagawin mo. So that is anti-logarithm. So pag in-antilog mo siya, that will be, it will be 9.12 or 9.12 watts. So as you can see, 10 watts yung tinatransmit natin or 10 watts yung galing dun sa source, pero ang nakarating dun sa destination is only 9.12 watts. So the question is, saan napunta yung iba? So yung iba is loss. So because your cable has 1.5 decibel per 100 meter attenuation. Okay? So ang goal kasi natin is maximum power transfer. So like what I've said kanina, so dapat kung 10 watts yung dito, dapat 10 watts din sana yung marireceive mo dun sa kabila. But since yung cable is merong loss, so mababawasan siya ng konti. So mas malaki yung mababawas dyan kung malaki yung attenuation. So the higher the attenuation, the higher the loss. At mas konti yung makukuha ng load mo. Okay? So also, kapag mas mahaba yung distance ng dalawa, yung source at saka yung destination, so meaning mas malaki din yung loss. So the higher the length or the distance, the higher the loss. So remember this relation. Ibig sabihin kapag mas mahaba yung cable, so mas marami siyang loss. So nakadepende rin dun sa length ng cable yung loss niya. Okay? So ayun yung tandaan natin. Okay, next. So sample problem number 2. So an SWR meter is used to measure the degree of mismatch on the line. So the SWR meter records 1.6 when the line is terminated with 50 ohms and 2.2 when the load is changed to 176 ohms. The question is, what is the characteristic impedance of the transmission line? So dalawa yung ano niya, for example. Pag una daw, yung ZL mo is 50. So ang na-measure na SWR dito, when your ZL is 50 is 1.6. Next, pinalitan yung load. So same transmission line, pinalitan yung load, ginawa siyang 176. Tapos nag-measure ulit ng SWR, so nagbago yung SWR, so naging 2.2. So the question is, ano yung ZO ng transmission line? Okay, so remember, the SWR is pwedeng ZL over ZO or ZO over ZL. So depende kung sino yung mas malaki. Pero since hindi natin alam yung ZO ng transmission line, so we can, or we try to compute first the two. Okay, so for example, dito sa una, so using SWR of 1.6 and using ZL of 50, and we try to compute first for the ZO. Okay, so gamitin muna natin to. So naman ginamit ko itong ZL over ZO. So mangyari dyan, 1.6 equals ZL which is 50. Raise muna natin to. Yan. So 50 over ZO. Yan. Gagamitin din natin yung isa. Kasi nga we don't know kung sino yung mas malaki since wala nga tayong ZO. 1.6 ZO over 50. So let's compute first ito, yung una. So mangyari dito, 50 over 1.6. So that is 31.25. So sa pangalawa naman, multiply natin. 50 times 1.6. That is 80 ohms. Okay, next. So yan yung sa 1.6 tsaka 50 ohms. So try naman natin yung 176 tsaka yung 2.2. So when the SWR is 2.2 and ZL is 176. So ganun din. So ulitin natin to, ito tsaka to. So 2.2 equals kapag nasa baba yung ZO and kapag nasa taas yung ZO. So, raise mo natin. This is 176. Yan. So, first, divide natin. 176 divide by 2.2. So, we have 80 ohms. And then, multiply. So, 176 times 2.2. Have 387.2. As you can see, since isa lang naman yung cable, so kung saan sila nagkaparehas, yun yung ZO ng transmission line, which is obviously the 80 ohms. Okay? So that's how you determine the ZO of a transmission line, so given yung dalawang scenario. Again, pwede kasi yung dalawa. Okay? So ibig sabihin, kapag ginamit mo yung ZL as 50, so magiging ZO over ZL siya to get the 1.6 na SWR. Pero pag ginamit mo yung 176, magiging ZL over ZO para lumabas yung 2.2 na SWR. Okay, so that's why we need to compute yung dalawang using the two formula. Okay, to compare yung mga value. So kung saan sila nagtugma, so malamang yun yung SWR ng transmission line. Since hindi naman binago yung transline, ang binago lang yung load. Ang pinalitan yung load from 50 to 176. Okay, next. Okay, so example. What proportion of incident power is reflected back from the load from a 75 ohm line terminated with 50 minus J25 ohms? So hinahanap niyo yung proportion. So parang percentage yung kailangan natin. So we all know that absorbed power is incident power times 1 minus reflection coefficient squared. A question, wala tayong reflection. So we need to solve first the reflection. Remember, reflection is ZL kasi ang given sa atin is yung line at saka yung load. Okay? So the ZO is 75. The ZL is 50 minus J25. So hindi mo pwedeng pagbalik rin yung nandun sa numerator. No? So dapat ZL minus ZO siya. So we have ZL 50 minus J25 minus ZO of 75, then 50 plus J25, then plus 75. So, kagaya na nabanggit ko kanina, so vector quantity ang reflection coefficient, so may phase angle yan. So, we need to use the complex mode so, para makapag-compute tayo ng complex numbers. Oh wait, so minus pala ito dapat. It should be minus 50 minus J25. So, gawin lang natin siyang phasor or ganito. So, 0.28, no? 0.28. Tapos may angle na negative 123.7 degrees. Actually, ang kailangan lang naman natin dyan is itong kanyang magnitude, which is 0.28, to solve for the proportion. So, ito lang makakompute natin dyan actually, yung part lang na to. Kasi wala siyang given na incident power. So, the percentage only. Let's try to calculate. So, 1 minus 0.28 squared. So, 92.6. Or 0.92. Okay? So, actually, in terms of percentage, so times 100 mo yan, magiging siya, 92.16% of incident. Okay? So, kaya lang pala, ibabalikan natin yung tanong. The question is, what proportion of incident power is reflected? So, tinatanong niya yung reflection. So, now, if alam na natin na 92.16% ng incident power yung ma-absorb, so, yung reflected niyan is equal dito. Diba? Incident minus absorb. So, this is based dun sa equation na to. Absorb power is incident minus reflected. So, if you want to get the reflected, so incident minus absorb. Okay. So, your incident is your absorb pala. Your absorb is 92.16% or 0.9216. So, your reflected now is equal to 1 minus 0.9216. So, 1 minus answer ko na lang. 10 times 100. So, 7.84. So, this is the reflected. So, ito yung tinatanong dun sa question. So, yung proportion or yung parang percentage. So, if 92.6% yung na-absorb, 92.6% ng incident power yung na-absorb, so meaning, 7.84% nun yung nag-reflect. So, that's how you compute for the reflected power. Okay? So, again, kapag hindi match, kagaya nito, 75 ohms kasi siya, so 50 minus J25 yung load mo, so hindi sila match, so obviously there will be a reflection. Okay? So, and the amount of reflection is 7.84% ng incident. And so, ganyan mo kukumpitin yung yung reflection and yung absorb. So, using this equation. Okay? So a lossless transmission line, 80 centimeter long, and operates at a frequency of 600 megahertz. So the line parameters are 0.25 microhenry per meter, and C is 100 picofarad per meter. So find the characteristic impedance, the phase constant, the velocity of the line, and the input impedance for ZL of 100 ohms. So marami siyang kailangan computin. Okay, so let's compute one by one. So the first one is the characteristic impedance. So since given ka ng L, so this is the, yung distributed parameter, so we can use this one, L over C, to compute for the ZL. So what is L? 0.25 micro over DC pico. Oh, 0.25 lang siya. So micro, and then 100 pico. So 50 ohms. So we have the ZO. Next, we need to compute for the phase constant, yung beta. So the beta, how are we going to compute for the beta? So the beta is the phase shape coefficient. Okay. So we can actually use this formula to compute for the phase shape coefficient. So given yung frequency, given yung LNC, so we can apply this formula. So again, yung omega is 2 pi f. Next, so 2 pi, so the frequency is 600 megahertz. And then square root of LC, so 0.25 micro, and then 100 pico. So 6 pi or 18.85. If ginamit itong formula, so the unit will be rad per meter. So initial degrees per meter. Okay. Next, so how are we going to get the velocity of the line? Okay, so kung meron tayong LC, so we can use this formula naman for the velocity of the propagation. And actually, this is derived from from angular frequency over beta. So we're in, and diba? So that's why na-cancel to. So 1 over square root of LC na lang siya. So that's another formula for the velocity of propagation. So let's try to get the value. So this is point square root. Then so this will be the velocity of the on the line. It's 200. What's that? I-mode 1 ko muna. 200 and 200 times 10 raised to 6. Okay? So try to remember yung mga working equations na ginamit natin for this certain problem. Kapag given yung LC, you can use this equation for the velocity of propagation, for the phase shift or phase constant, and for the characteristic impedance. So the last thing that we need to compute is the input impedance. So the input impedance, natin lalagay. So isog ko na lang muna dito. Yan, hindi na siya kasya. So the input impedance Z in is equal to ZO, quantity ZL plus J ZO tangent beta L over ZO plus J ZL tangent beta L. So the ZO that we've computed is 50, di ba? 50 ohms. The ZL is what? Let's go back to the problem. So the ZL is 100 ohms. The transmission line is 80 centimeter long, or let's say in meters, this will be 0.8 meter. Tama? Yan. So again, ZL is 100 plus J 50 tangent. What is beta? Yung na-compute kanina? 18 point, 18.85. Yan. So 18.85 multiplied by the length, which is 0.8 meter. Then 50 plus J 100 tangent. Yan. So take note, ang unit nitong beta, yan, is rad per meter. And then nagka-tangent ka. So yung make sure your calculator is in radians, since naka-degrees kasi ito. I-convert mo muna into radians, since radians ang nasa loob. So take note of that. No? So baka kasi naka-degrees ka, then nag-compute ka ng ganito. Tapos yung unit kasi ng beta mo is radians, so dapat naka-radians ka din sa calculator. So don't forget to change your calculator mode. So I, so dapat naka-complex pala ako. So 50, 100 plus I, 50. Baka siya, hindi natin ng parenthesis. 50 tangent 18.85 times 0.8. Then sa baba, wait, bakit 10? That should be 100. 100. Then 50 plus I, 100. Then tangent times 0.8. 0.8 is the length, okay? Yung 80 centimeter, na-convert natin into meter. Should be meter kasi ang unit nga nito is rad per meter. So to cancel out yung meter, it should be meter. So the answer is 49.13 plus J, 35.5. 0.04 ohms. So that is the input impedance. Okay, so that's how you compute for the ZIN.